probably want to delete it after this is over, or email it to yourself. This is bigger than the OIT will allow student accounts to have, and it'll mess up your profile throughout the whole university if you leave it on. It's actually attached to a bigger thing. That's got 3. So the problem is I got like a 32 external. And then I was like, oh yeah, I've got 3. Should I get 64? How do you find? No, I now have a 4 terabyte. I have a 1 terabyte, 4 terabyte hard drive. Like I think my biggest issue is data storage.
Oh yeah. I bought an iPhone 7 last year, and I went ahead and got the 128 gig.
I actually just got 128 gig iPad.
I'm telling you what, that is the #1 best thing you can do for yourself.
Yeah.
If you use your phone for.
So I have a 32 gig iPhone, which has been fine. I actually got the iPad. I'm gonna make
Protest progress.
So actually, I got the iPad because I have TeamViewer installed on my laptop.
Yeah.
And you can like push buttons from TeamViewer on your iPad.
Okay.
So I don't have to carry my 17-inch laptop
That's awesome.
if I have the iPad.
That's cool.
Yeah. So.
Yeah, I told you, maybe I told you, I had 2004 and 2012
Yeah.
national inpatient data, 37 years. I realized I could store that on my phone.
You
Like, that's
know-
a space app.
You know that my dissertation topped out at over a terabyte, right? My dissertation topped out at over a terabyte.
A year. Really?
Yeah.
All the data?
1 kilometer for the whole globe.
Okay. Yeah.
For 21 environmental and species occurrence data sets. Do you need data? Okay. Good luck with that. So there's a file in here. To start off.
We had and they didn't like reality. Are we supposed to?
Well, so you can run along. I've got a toy data set.
Thanks. Thank you. Got it. That works.
I wasn't gonna say it. I mean, I passed a fit, so I guess I can say it now, but I wasn't gonna say it. Just in case. Yeah. GIS data. Just the whole folder.
Just pull it onto the.
Yeah. Where? No, the other one's over there. So when you're done, you want to get it. And so you can go ahead and into your start menu and just open Arcmap. So the here, and then just type in here. Use it.
Oh, God. Wait.
And are we recording?
Yeah, we are.
Okay.
So what are your, well, everybody's doing it, I
You
guess.
can do it.
There's free software for this kind of stuff.
So, like QGIS and GIS, and so they're supposed to be really good, really great functionality. We teach our GIS here, so that's what I know.
Yeah,
But I've also heard it's really transferable.
okay.
But I haven't. So GIS actually has some of the best publicly available data sources in terms of like base maps and stuff. So they're a really great resource to use anyway. But I haven't used their actual software much. They will create certain variables for you that ArcGIS won't. So I've done some variable manipulation as well.
Which one are we opening?
Arcmap,
Arcmap 10.4?
yes. Okay, we'll go for just a minute to get logged in and then we'll get started.
Yeah, so I have a friend of mine, she went to the geosciences program here.
Yeah.
She works for NC
Okay.
doing some map work for them. She loves the freeware, but it's a common issue if you get
Yeah.
out of skills, it's not, it's not the same.
Yes, software usually Amazon. So I started at this and then I went to 64 and now I have a 4 terabyte hard drive. Alright, so we can go and get started. And I'm gonna try to do this touch screen. I may have to move to the mouse. But to start, you should have this Arcmap getting started. And it says blank map. This is just a template. So this is where you're gonna start and hit OK. And so what I'm going to do, I've got a toy data set. We're actually using the Tennessee State base map, and we're using Tennessee County Health Ranking STI rates. And I'm going to show you how to visualize those on a map by county, and then I'm going to show you how, if you don't have subsetted maps, to create the polygons you would need to visualize things by county. And I've got a PowerPoint that shows some instructions on this that I can distribute afterwards. I can't display them both, but it's got some links and some of the file paths and stuff. A really important thing when working in GIS, you cannot have spaces in your file path because it can't parse spaces, so it'll crash. So at your entire file path, your C, so C, Julie, GIS data, GIS has that's why it has an underscore, so that the software can parse that file path. When you first open your GIS, you go to a blank template. You're gonna go, oh, I'm too short for this. File. Go to File, and you're gonna go to Map Document Properties. And we're gonna need to do two things here. And this will be in the PowerPoint, I'll distribute. You have this store relative path names to data sources. So you're gonna click that box. What happens when you put a drive into a computer is that drive gets randomly assigned a letter. That's why sometimes your thumb drive's an F drive, sometimes it's an E drive. What this says is look for something that looks like that. Don't necessarily just look for the F. So when those change, you won't lose all your data. The other thing we're going to do is go to this file here where it says default geodatabases. And see how there's this connect to folder. So we're going to connect to your GIS data folder. So you should just be able to go to desktop. I don't have it saved on my desktop, but does it pull up on your desktop when you? Yeah, so there's a folder that says GIS data. Click that. And now there's what looks like a barrel. So give me just a sec. So see how we've got this guy up here that looks like a silver barrel with a little star. Can we? That's called a geodatabase. When you create certain types of data in GIS, it puts it in a geodatabase. So you're going to create a default geodatabase here. I've got one that's called College of Public Health Geodatabase. So click on that. And name it whatever you want to name it as long as it doesn't have a space in it. On that one, that means that we can create a new And then just name it whatever you want to name it.
So is this essentially like a lib name statement?
Yeah, for those of you whose SAS, this is just like a lib name statement.
Can I have some help, Professor? So I'm not. This is good. This one?
Yeah.
This one. Just call it something.
Just call it something. With no spaces in it.
She's got.
There's a file in here called GIS data. Just put it on your desktop. Alright, coming.
So,
So go to the winner. To the Arcmap.
So I think what we just did is created just a repository for whatever data.
So what happens when you're working in GIS data, I'll show you, is it creates a bunch of files that are kind of look like gibberish. You can see all these right here. And you can't open any one of these individual files. So what the GIS data or the Geodatabase does is it tells Arcmap all of these go together, and when you read them in, what you'll get is a shapefile that I can work with. So if any one of those components is missing, it won't work. So by putting it in a Geodatabase, we tell Arcmap all of these are right here.
so you have to save all of them together.
Pretty much.
Basically, by
But it will
saving
automatically-
folder.
It'll automatically do that for you in that Geodatabase, which is why we set a default.
Excellent.
So now that we've got that, we can close the map document properties.
Is that supposed to be in a particular folder?
You can put it in the data folder. It can go, if this is your computer, it can go where it is now, which is on the C drive.
Okay.
It will matter less and less if you're moving from computer to computer. Put it in the file with your data and just navigate to them. Now we're all going to go to File and Save As. And we're going to save this on your hard drive, on your desktop in that GIS data folder. And again, you can save it whatever you want to save it as, just no spaces.
I'm excited about it. Look,
And then you
That's where we are.
like Friday, so I'm excited to have a bunch.
have document properties.
So she's like, she's gonna be having chickens in the basement. She's making some today.
What do we do after this?
So, hold on.
Yes. And now create the and maybe save it whatever you want, just make sure there's no spaces. You guys good?
access, what?
We have one of those.
It's now where it's gonna get you all the. So we added that. That's what's gonna happen. Okay. So predict what's gonna happen. So auto save or something. Oh my God. See that name? With no spaces. So now we're good to go.
You did.
All right, we're good to go.
Alright, awesome. Listen, you're gonna need the data. So there's a folder on here that's just called GIS data. So save it to your. Alright, so now that we've got that, we're gonna add data into the map so that we have something to look at. So there's this little square here with the plus on it. I'm gonna click on that. Nope. It's not calibrated.
Yeah.
And so you just created a folder connection in your last step, so you should be looking at your GIS data folder. If you're not, let me know. We can fix that.
It's one of the four things that say.
Yeah, that's fine. So click on that folder, and you've got a folder in there called Tennessee County. And then there's something called Tennessee Counties.shape. So the way I got this is called a base map. And we're going to hit add. So select it and hit add. And you should have a really nice map of Tennessee with all the counties on it.
Alright, so, sorry, but I don't have that.
I'm sorry. Go ahead.
Had it?
Yes.
She didn't have write access to her desktop.
Okay. Here's my right. If not, you can keep it on drive and work on it. If you're working from Z Drive, you will want to delete this or email this data after yourself. Having this much data on your Z Drive will mess your account up all across campus. Trust me, I know. I do this all the time. So what we have now is a file of a shapefile of Tennessee that has all of the counties on it, and this is called a base map. So it's kind of our background map. We're going to work from this. This is a publicly available data file. I got it from the GIS online. The URL for this is actually in the PowerPoint I'll send to everyone. And Google has a phenomenal number of these base maps. So you just Google, I want the Tennessee County base map or shapefile, and you'll find it. And you can download it and use it. A really important thing when working with maps is projections. So your maps, when we're working with maps, we have a round world and we're trying to put it on a flat surface. And that creates all sorts of distortion problems. So several different systems have been created to adapt to that problem. You need to make sure that all of the maps you're using are in the same system. Because if they're not, things that look like they match up may actually be several meters off. So you go into we've got this Tennessee counties here. You're going to right click on it and go down to properties.
Okay, so right click on your
Okay, where's my other? Tosin, did you finish with that one drive? It's copying. It's copying.
that's as far as we got, but we're looking at projections.
Cool. I will get you the data in just a second and we'll get you caught up. So going to source on that land properties,
Source, okay.
and what you can see is you've got this geographic coordinate system and data. Problem? Okay. So a geographic coordinate system, like I said, is the way we've created to deal with the fact that the Earth is round and computer screens are flat. There's several of them. The datum is the central point. So the North American datum is actually in the middle of Kansas. And it's where we start gridding things out when we create a map. It's really important that all of your files are in the same datum. And a little bit later, I'll show you how to change the projection if you get one that's in the wrong datum and coordinate system. But that's just something you need to check. So here we know we were working with the North American 1983 datum. We can close that.
Okay.
So we're going to go back to that add data, which is our little plus over the square. Go up to our, you'll have to go up one because you're still in the Tennessee Counties file, and there's an Excel file in there. There's actually two. We're going to pick the one called STI rates. When you double click on it, it's going to ask you if you want sheet 1, and you're going to pick sheet 1 and hit add.
No STI.
Yeah, no, STI. Well, that's because we haven't we haven't joined it yet.
Sheet one?
Yeah, sheet 1.
Add.
Yes. So this is the county health rankings data. You can't see it yet. I'm going to tell you how to see it in just a second. Just type in. That's yours. Do you want to remove, if you've added the wrong one, right click on it, and it'll remove a problem. Sure. Yeah.
Just wherever the data lives, for the Excel sheets. We want to do it with one that's in the averages.
So did you agree with what you said? So we actually need to go here. The actual. So where did you put on in your Z drive?
This is cool.
And now
You're going to do the same Excel sketch? Kill it.
Yeah, I mean, I'm having to really get good at it.
Yeah.
So,
So
I'll
you'll
take
connect
I
before,
think it's definitely something.
and then you just, whatever the GIS
It's like
will
this.
next step, and then you'll go to navigation. Yeah, team counties and then SJ data.
And that's essential.
Alright, so does everybody have so you should, in this pane here that shows what data you have, you should have Tennessee counties and you should have this sheet 1. Does everybody have that? Okay, so now we're going to create what's called a join, which is just like anybody who's ever merged data. It's just like merging data. You'll get two options. So we're going to right click on Tennessee counties. And you see this joins and relates.
Right click on Tennessee.
We're going to add a join. So the difference between a join and a relate is a join is like merging two data sets with a unique identifier. A relate is creating a relationship. So in join, what we're telling it is we have a data set that's got infectious diseases, we've got a data set that's got counties, they can match on a unique identifier. When we relate them, what we're saying is we have records of all the people who are identified in this county and we want to be able to look them up by county. We're telling it if there's a relationship. So right now we're joining. Choose the field, it's going to be name. And then choose the field in the base table to join on, it's going to be county. We can hit validate join and it'll tell us there's one name that contains invalid characters. I know that, it's my header. Because it's not the same in both, so that's fine. We're going to hit OK. We're going to close.
We're going to click validate first?
You can, yeah.
Okay.
And what it'll tell you is that there's an entry that contains invalid characters.
Right.
And we know that that's fine. You guys are lucky I went through and cleaned this up before, so everything's going to match. Usually you would have to make sure all the counties are spelled the same way, capitalized the same way.
Really?
And then hit OK. And so now we're going to go back to Tennessee counties. We're going to right click and we're going to open attribute table. And if we scroll all the way to the end, we can see that we have a column that says sexually transmitted infections.
So what we've just done is joined basically
We just
a
merged two data
spreadsheet.
sets.
We
Yeah.
geo-referenced a spreadsheet
Yeah.
basically with all these variables
Yeah.
and data, which is so good.
Yeah.
It's so
Isn't this amazing?
That is really cool.
Yeah.
So these are numbers of infections.
They're rates.
This
So I
these
pulled,
are
I pulled the
rates.
rate. Yeah. So this is county health rankings.
So sexually transmitted infections is a rate.
Yes. It's just that it's actually chlamydia rates for the county health. That's what county health rankings uses. And I don't know what it charges from.
for 1,000.
I don't.
Can't
Maybe
Yeah, it's gonna be
no, is it?
100,000 or 10,000.
Yeah, it's gonna be 100,000. Yeah.
Yeah. Okay. Yeah.
This is what GIS is.
Let's see maybe that's a manipulated infection. That means we're joining.
This is what we look at data now.
So close your attribute table for a second. Right click on sheet 1.
Close it without doing anything to it?
Right.
Not selecting it? We don't want to select that column?
No, you don't. It doesn't matter. Right click on sheet 1 and open that attribute table. So your attribute table is basically your data set.
Yeah.
And you'll see that all you have in that is a county name and a rate for STIs. So that's what we just joined together on the county name.
Okay.
I don't see this sheet.
Okay. Okay. So see. Yes.
No, don't click.
So you, yeah, it's okay. So go to the last column. The last column is sexually transmitted infections. And then go ahead and close that. Yeah, either one. And then go.
So you need to add the Tennessee data to the folder and then add it.
First option.
And I can change it. Yeah. So this is it. Yeah, no, this is the county shape. I already have that. Yeah. Well, I think it's STI rate that I selected. And then it's going to pop up sheet 1.
So this is alphabet. The other one was not.
So we can actually sort alphabetized, it's really easy. Right, open the attribute table, right click, and it'll sort of ascending
Okay.
on the column you want.
Right. And it'll sort the whole table?
No, well, no, it'll just show. Yeah, it'll expand to sort.
Yeah, I got it. Cool.
No, it's really quick.
It's the same, these are the same numbers.
Yeah, that's because we joined them.
Second one. Okay. I think I'm keeping up.
I want to figure out correct.
So it was called county in the table, and it's called name.
Yes, they got different.
Gotcha.
They don't have to have the same unique identifier, you just have to tell what the unique identifier is.
So this one is our layer, which is the map.
right, so is everybody pretty much there? Got that?
Just like,
All right, so now we're gonna go into this Tennessee counties. We're gonna right click and we're gonna go to properties. And we're gonna go to the symbology tab. So we have a number of options here. Right now we've got it all displayed as a single symbol. But let's say we want to display STI as categories. We're going to click categories. And we're going to scroll down to the bottom for the value field and select sexually transmitted infections. So now we're going to, actually, I'm sorry, let's do this. Go to quantities. So right now it says categories, go to quantities. For the value, go to sexually transmitted infections. And see how it gives you a number of categories to start with? We can tell it how many categories we want. We're going to classify. So it says classification, natural breaks, jinx, classify. And we can actually tell it what we want those breaks to be. So say we think that like 0 to 5 is really low, and so we want to make that low. And then 5 to 7 is moderate. We can do that. We can create as many categories as we want, and we can name them whatever we want. And then we can get them to display visually. So for now, we'll leave it at the 5. So just hit cancel. And we're going to hit apply and hit OK. So now you have a map that's showing by color STI rates for every county. And then just hit OK. So hit OK. Yeah. Oh, you're fine. You just have to see it. So go to quantities.
So did that just break them into quintiles?
Yeah, it's quintiles. And then hit OK. No, that can't be quintiles. It's based on values because that's not 20% for each color. So it created a. It's not quintiles. It's not 20% in each color.
Yeah. Okay.
Right. It's just
It's just
this
a
is
grading.
5
Yeah, it's just graduated.
Yeah.
Uh,
Were we saying?
Are these really rates?
this is what kind of help I can.
I mean, they do give you raw numbers, rates, and so you
I was pretty sure I pulled the rates. At the end, I'll pull up the file we can check. So this is the best case scenario. This is when you can find a base map that's got what you want. It's when you've got fairly nice data that match really well. So, and I'm going to show you one more thing on this one. If we want to display the numbers, say, so we've got this, we want to see the rates overlaid on the map. We're going to right click, and we're going to go to label features. So right now we've labeled it on counties, because that's what the default was. But we can right click, we can go back into that properties, and go to the labels tab. So we've got name, but we can go to the bottom and we can say sexually transmitted infections and hit OK. And now we've got the rate displayed on our map.
Man, that's awesome.
Yeah, that is kind of good. So is everybody at that stage? Okay, so now let's say that for some reason we just want to look at Johnson City. And we want to create subgroups in Johnson City. And I've actually made up some data for this one because we didn't have a good data set. But so we're going to add data again. And you have a Tennessee City file in there. So double click that and add that shapefile. And it's going to make your shapefile look really crazy. That's okay. On your display here, you have two magnifying glasses and then you have a hand. Click on the hand. When you have that hand, you can move your map around. The plus and minus are zooms, which you can also do with your scroll wheel. But we just want Johnson City. So we're going to go back into our attribute table. So right-click on Tennessee City boundaries. Open attribute table.
And can we slow down just a second?
Yes.
So I'm trying to find the data again. Tennessee City. Add this. Oh, okay. All right. So just double click on it. Cool.
Use brush. Yeah. So add your
Needs me over here.
Wow. It's really neat.
So open your attribute table for the city shapefile and go to this, it looks like a to-do list almost, in the upper right-hand corner.
Open the attribute table means right click on it.
Yes. And it'll open up a submenu that we want you to select by attribute. So, if you have written any sort of SAS code or anything, this is pretty easy. It's actually Python code, but it's the same basic principle. So you're going to click name, and so what we want to do is we're selecting Johnson City. We're telling it, we know we've got a bunch of cities here. I want you to highlight Johnson City and show me where it is. So click name, click equals, and then if you know how it's entered in, you can actually type into this field, or you can hit get unique values. And it'll give you the names of every city that's in here, and you just scroll down to the J's and find Johnson City.
So double click name, then click equals, and then
Get unique values,
get unique value.
double click that, and hit apply. And so we can close that window. And you see how right here I've got this little blue county? That's Johnson City.
Oh, yeah.
Yeah.
And then close out the.
Yeah.
Oh. What's that sound?
What's right? So that's Johnson City.
Okay. It's just giving me a boundary.
Yeah. That's the city boundary for Johnson City. So does everybody have that? They've selected their city. We know where Johnson City is. All right, we'll give them just a second.
I know. That's what it was.
Equals.
All right, on our city boundaries, gonna go to data.
On the boundary.
Yeah. So in that pane that's got all of our files in it, go down to data, and we're gonna export data. And we want to export the selected features. So if your Arcmap says not responding, just hang out with it. About 95% of the time it's thinking, about 5% of the time it's crashed. If 10 minutes, 15 minutes later you're still hanging out with it, restart it. But, so like Iz is doing this, we're just going to give it a minute because it may decide to join the party.
Oh, done. No, that's it.
We can add it back. Okay.
Sure.
So you can just reopen it. We'll have to recreate this one. Oh, you're fine. So go to right click on the TC battery.
Yeah.
Okay. So we're going to export selected features and we're going to put it in that Geodatabase we created. So if it doesn't show yours that goes to that GIS data folder on your desktop, navigate to that. So when you click on the file, you should see the Tennessee City or the Tennessee counties. Then you'll know you're in the right place. Give it a name that's something other than export output because it will name every file export output. So I would call it Johnson City. Yes, you do want to add the data to the map. Great. And then name it something else. There you go. Yeah. So give it a try. Well, actually, so add that in something up. All right, so start to jump. sometimes it's picky, and different installations do different things. It's crazy. So sometimes the answer is just play with buttons until it does what you want it to do. It's a very technical response anyway.
Yeah.
I wonder what happens when I do this. If you get this error where it says an error occurred trying to save the object, change it to a shapefile and hit save. And then hit OK. You do want to add the exported data to the map as a layer.
So we replace it, right?
Pardon?
One says.
If it's already on there, yeah, just say yes to replace. I may have created one for you guys, and now you're creating a new one.
Okay. Now after that, what does it say?
Drop down here.
And change it to shapefile. And hit save.
Let's say it's.
Okay, so now you just hit close. Yeah. Yeah. And I got it. So everybody's got a layer named Johnson City added to their. So go into the properties and look in that source, like remember I told you about projections. It doesn't matter so much here because we're not going to try to reconcile this back to our map, but this is actually in a different projection than our Tennessee state map is, which is really interesting because these are both part of the Tennessee-based mapping project. So the same website has two different projections. I'm going to show you how to project it, but we're not actually going to project it because that takes a really long time and is a step at which GIS tends to crash. But so you've got, see the little toolbox here? When you mouse over it, it says Arc Toolbox. Double click on that. Go to Data Management Tools. Projections and transformations. It's like, so yeah, in case you hadn't realized, GIS has an amazing amount of capabilities. I know like maybe a tenth of these. So but there's a lot. It's a really powerful software. Projections and transformations. Project. And then we would tell it, okay, we want Johnson City. And then we would navigate to the output coordinate system, which is the one we want, and we want it to match our Tennessee map. So, and don't do this part because I don't want a whole bunch of GIS software to crash. But we're in North America. We know that our other one used the North American 1983 projection system, like I showed you. We go to that. We're going to go to NAD 1983, and that's what we would project into, so that our Tennessee state and our Tennessee cities matched. This really matters, so like Johnson City, or so if we were going up to Sullivan County's on a border. It could be really problematic if in one projection Sullivan County's in Tennessee, and then the other projection it extends a couple feet into Virginia. Which may not matter so much for us, but really matters if you're doing something like drawing an election district or trying to allocate resources. So that's where this really gets problematic. Or say you want to tell someone where the edge of a cliff is. That's, then a meter really matters. So we're just going to cancel out of all of that. We've got a little box up here. We're going to click, it says clear selected features. So that just gets rid of our Johnson City where we had it selected. Now the only file I want to keep up is Johnson City. So see how these have checkboxes next to them? And should go in and check them, uncheck them. And then we can zoom into Johnson City. Now, normally I would not just arbitrarily draw shapes. I would have some sort of map, some reason I'm drawing them the way I'm drawing them, but I didn't have a good data set I could share. The only one I have for this is embargoed right now. So I just made up a data set for you guys. So we're going to draw 3 polygons and we're going to link them to data. In your customize option, yeah, and the great thing about that checkbox is you can check and uncheck them as much as you want. It doesn't take the data away, it just gets it out of your way. So So we're gonna go to customize, and we're gonna go to toolbars, and we're gonna pick the editor. And you're gonna get a toolbar that's gonna open up. Did you crash?
Yeah, mine's taking a little while.
It's okay, give it, we can. So the reason this takes a really long time is you're working with really big data sets, and we're probably looking at 8 gig processors on this computer. So it takes it a while to run everything through the random access memory. Just give it a minute. This is very interesting over there.
That's why absolutely, yeah. Absolutely. For Congress, absolutely, it's horrifying. North Carolina's the worst in there. Yeah.
You crashed. Oh, you really crashed. So reopen it, and I'll get your data back up. So pull our map back up. GIS is basically bigger than the processor on most computers can handle. When I was working on my dissertation, I had a friend who gave me some access to a computer with a 256 gigabyte RAM, which was phenomenal. It was incredibly fast, but we're probably talking 8 gig of RAM here. So it's having a really hard, the hamsters are running really fast. In the geosciences department where we have a lab for this, we have 64 gigs of RAM.
So mine also crashed.
Yours also crashed.
So
Yeah, so. Yeah. If yours has not crashed, just go ahead and hit save. If yours has crashed and you've reopened it and gotten it back up, also hit save. And save early, save often.
Now, do we need to save it in the ArcGIS or in the
Save it in the file where it's in now. So wherever your GIS data file is, you can just save it there, and it should be saved as a .mxd. An interesting thing about this .mxd, this is a map document. If you try to email this, all right. Some of you may not be able to do this step. I will show it. Some of the other computers around campus may have better luck with GIS. I've never tried to use it in here. So if you can't get this to work, just watch. And then I'm gonna, this evening or tomorrow morning, I'll send out my PowerPoint, and I'll include some more detailed instructions so that it's just incredibly step-by-step and granular. Since we didn't get to do that. But so when you save a map document, your computer is saving file paths. If I were to take that map document and email it to Billy, what he would get is a really broken map document because he wouldn't have the data files. So at the end, I'll show you how to wrap up the map document and send it all so that it's actually usable. So I got an editor open because I'm lucky. And we're going to hit Start Editing. I'm going to pick Johnson City because what I want to do is draw polygons in Johnson City. If you have not crashed, if you've managed to get to this step, follow along. If you have crashed, just pay attention. Yes. Okay, so you're really well. Click Start Editing. and then Johnson City, and then we're gonna hit OK. Spatial reference doesn't match data frame, that's what I was telling you about. The states in one, the cities in the other. GIS is gonna make them look the same, but they're not. That's okay, we know that. So I've got this Johnson City polygon here. I'm gonna go to construction tools, and I'm just gonna draw rectangles. You can draw any shape you want, you can go crazy. But I just want to do rectangles. And then let's say I've picked 3 sub-districts in here, and I've got STI rates for those 3 sub-districts. So I'm gonna draw them. Normally I would have a map, I have coordinates, I'd be putting them on, but I just want to show you how to do this. So grab it, make a line, make another line, double click when you're done. If you do that, just hit escape. I'm gonna go to Johnson City, and I'm gonna open that attribute table again. And you can see now that I've got a 1 that says polygon.
And it's got the geo-coded
Yes.
coordinates for that.
Yes. So I'm going to go to that, and I'm going to name it sub-area 1, because I've already created a file where the heading is sub-area 1. Now let's say, I misspelled area. So I have another polygon I want to draw. I took a sample from up here. I may have just crashed. Wait a minute.
So to run ArcGIS in here, we would need to upgrade these.
Yeah, they probably need
These
more.
what are they called? Thin clients. Right. These are from.
Are these thin plans?
Yeah, these aren't college public health. These are university thin clients. I think that's what they are.
I'm gonna look at what the RAM is. So it's probably the thin plan. Tends to have issues billing to and from the server on larger programs and SAS.
Yeah. I remember SAS is a real problem.
So we may need to, yeah, you're done. So we may need to get off if we're running here, you get off the thin plan. If you need a GIS license, Geosciences has free 1-year license for student staff. You just talk to Andrew Joyner. So we get him as part of our enterprise package. If you talk to Andrew Joyner, he can get you a free 1-year student license.
Do they work with Max?
I believe so.
What's his name?
Andrew Joyner. He's gonna kill me for telling you this. His email address in the system is Timothy Andrew Joyner. So I have frozen the time. So what I was going to do was create another polygon. And then do the relate step that we did before. And it's the same. So I have a data file in your data that is, I think it's just called subareas, and I just made up some numbers, and it will relate the same way we did that county STI rates. And so you can draw polygons, and you can relate it to it in the same way.
Do you need to draw the polygon first, or will it just read it?
You need to draw it. So that's what I was just doing. If you have, like the counties, or if you have a map that's already got those polygons on it and they're named, you can merge it. It doesn't have to be counties, it can be anything. I was working on a map. We had a Megan Quinn's research team works in a refugee camp in Nicaragua called Nueva Vida. They had a hand-drawn map. So what I did was I took a Google map and I pulled the image into ArcGIS and I drew polygons for each of our neighborhoods, and I was able to overlay mosquito data on the polygons, which was great because we were also able to update their hand-drawn map to a spatially correct map with the neighborhoods they needed on it. But because that map didn't exist, I had to go in and draw each of the squares for the neighborhood, and then I had to link it to the data set I had. You're not likely to have to do that in the US because we have such good data, but if you're working in the developed world, if you're working in somewhere that maybe a really rural area, you'll be less likely to have this really nice shape file that we started with. But as long as you can link on some sort of identifier, you can display the data the way I showed you. So I'm going to skip over drawing the polygons because it's obviously not working on here. But we will...
Is the unique identifier in that case going to be the spot on the map?
I gave them names.
You gave them
So we had, there were 5 etapas. and each tab had a number. So I named them, 1A, 1B, 1C, 1D,
Right.
2A, 2B, and that was the identifier.
But in Megan's case, right?
Yeah.
Did they just put a marker down on a GIS with the GIS tool, and then use that data for where that mosquito data was collected?
Yes, basically.
So they took the they got the physical coordinates,
No, so they got the household number,
the hassle.
and then I took the household number and georeferenced it correctly on the Google map.
Just based on satellite imagery.
Yes.
Okay.
So I
you saw rooftops.
I can actually. Oh wow.
But, yeah.
We may have actually just crashed the soft client. This would not be the first time I've done this. Vincent Thompson loves me. So remember how I said if you send somebody a map document, what they'll get is a broken map document? That's what that red arrow means. It means that I opened one and it doesn't have the file path it wants. I can click on that red arrow and I can say, oh, that's Tennessee counties. And now it works. You just have to tell it, okay, the data's moved, here's where it's moved to. But so what I'm going to show you now is how to export this map. So if you want to try to reopen your maps where it was before, don't worry about the customize option. We'll see if we can export maps and show you how to make a pretty map that you can distribute.
We're not going to go to
No,
city.
Pardon?
We're gonna skip the city example.
Yeah, because it's not going to work. It's going to go crashing. If you really, really want the city example, I can show you on my laptop.
Okay.
I just don't have it right now. So there's a couple things you need for a good map. A title, a legend, a scale bar, and a north arrow, so that people know what they're looking at. So when you're looking at your GIS window, go ahead and try to open your file back up, because we're not going to do those same processes. So you should be able to at least follow along for this part. In this bottom corner down here, it's a little bit hard to see, but you've got a map and then you've got a piece of paper. Is what it looks like. Click on that. And so that's your viewer, your layout viewer. And so this is how you format it. So it's right here. Depending on what you're doing, so it's standard in portrait. Tennessee's a long 16 state, so I usually do it in landscape. So go into File, Page and Print Setup, and just change your orientation to landscape. Hit OK. And now your data frame's a little bit outside. You can just resize that. And we see that Tennessee fits in here. You can use the hand tool and zooms to grab it so that it fits inside the box we're working in. You may need to re-add Tennessee, just hit the check boxes. Oh, okay. You're already in it. Yeah. Okay. And now you can resize this box so that it fills the hole. Yeah. And you can grab the top piece of up. Grab it. Try to make it fit inside your cover. There you go. Did you not save your last one? Okay. Alright, so we take a record, and then you can do this. And then you can move this around. Are you trying to join it? Alright. In your, so does everybody have something that looks somewhat like this? So we're gonna go to insert, and we're gonna insert a title. And we're gonna name our map whatever. Don't ever name your map that. So we may need to play with it. We can go into properties. So right now it's Arial 16. Properties, change symbol, and that's where you can play with the text. So let's say I want it to be 8, and I hate Arial. I want it to be in Times New Roman. You can play with colors and stuff in that too. So after you've done that, you'll hit insert again, and you want to add a legend. We've got Tennessee counties. So I don't usually, this is all formatting stuff, it doesn't make a huge difference. You can just finish. And what you see what we've got here is a legend that shows, okay, what do the dots mean? And we can go into the legend here, and so let's say I don't want all those zeros, I just want it to say 8. I can click there, or I can delete all those zeros, and now it's just got an 8. So I can clean it up as much as I want to, make it look as. Next, we're gonna add a scale bar. All of this is in insert. It's gonna insert a scale bar. I like this alternating scale bar just because I think it's really easy to read, but you can add whichever one you want. Okay. Move it down. Right click on properties. It starts in imperial and freedom units, but you can make it metric, which is what I usually do because everyone but us uses the metric system. So kilometers. I usually make it say km, so you can change how the unit is placed. Hit OK, and then to size this bar. It's really hard to read, but here we've got 400 kilometers. As you grab those sizing bars, the distance will actually scale. Can you guys see that bar now? So see how when I grab it, now it's 440, now it's 480. In map making, it's good practice to use a good round number, 400, 450, 500. If you're doing global, like 10,000 kilometers, I think is what my dissertation maps were in. And then the one other thing you need to add is a north arrow. You can pick any one you want. It just says, okay, so this way is up. This is how it's oriented, because if we're looking at it the other way, we just need to know that. And that can be sized. So once you've got all of that done, once your map is actually the most awesome map ever, we're going to go to File, and we're going to go to Export Map. I usually export them as a JPEG, which is an image file, because that's what most image software can read in. If you're exporting it for a journal, you need to make sure it's pretty high resolution. So like a lot of journals have a 300 dot per inch minimum. So that's where you can adjust that. And then you give it a name, you hit save. and we have a map. Now, what it exports is going to be exactly what you have on there. If you don't, so make sure that it's sized the way you want it, make sure it's zoomed in the way you want it. I often do find that I have to go in afterwards and crop out white space before I put it in my journal or my article or my Word doc because it will export more white space than I want. That's fine. You can do that in Paint and you can just crop it. Just make sure to save it as a JPEG at the same resolution. Now, if I wanted to email somebody this data set, what I'm going to do is go into File, and I'm going to share as a map package. And it gives somewhere to put it, so we're going to put it here. It asks for an item description. No one will ever see this item description or the tags. Analyze. And then you hit share. You ready for the English? The map document has changed and need to be saved before creating the map package. Would you like to save it? Yes, I would.
So when mine says share,
When yours says what?
and when it says share, there's nowhere to share.
So do you have a file system? Oh, so it's going to share it to that file. It's going to save it. So see how here you go. So you have to go to the item and you have to put something in this. It doesn't matter what you put. I just put gibberish in there. So when you email somebody that MPK file, what they'll get is they'll get the map you created, and they'll get a zip file of all of the data that goes with that map. If your data is like my dissertation and it's a terabyte, this is going to take 20 minutes to run, and it's a huge file, so be aware of what you're sending people. But this is how you share, okay, I've done all of this work in GIS and I want you to have all of it, not just the finished map. But be aware that you're also sharing your data. So if you're working with embargoed data and you send someone a map package, they have your embargoed data now.
So can we save this picture, this as a picture that JPG?
Yeah, so that's what when you export the map, you're exporting that map as a JPEG.
Oh, okay. Can we copy and paste directly to the Word file?
Directly to where? A Word file? Yes, you can copy that JPEG directly into a Word file.
Oh, okay.
I do it from Paint. It doesn't copy out of here well. It copies out of Paint really well. So I usually open the JPEG in Paint and copy it in. Another thing that should be noted is if you're sending someone a JPEG, and this is a data ethics issue, either send, if you trust them, you can send them a JPEG, or you can send them a PDF if you do not want them to be able to manipulate your JPEG. So depending on how you think your data is going to be used and what you're comfortable with, sometimes I will send these, I will actually turn the JPEG into a PDF and I will send a PDF. Because then if you change it, you did a lot of work to change it, I sent you a PDF. So that's, I'm sorry that it didn't all work, but that's what I have to show you today. That's how to get from, okay, I have some data, how do I map it? I'm gonna get a piece of paper and I'll just get everyone to write their email address down so that I can make sure you all get the PowerPoint. Probably get it out to you tomorrow with some really specific instructions that'll show the file paths we use. Go to this menu, click this menu, click this menu. And then after I send that out, if you have any questions, feel free to email me and I will be happy to answer that.
Julie, this was fantastic. I really appreciate it.
I'm glad.
First of all, let's give Julie a hand. Quick question.
Okay.
Can you show us some cool maps?
Yeah.
And tell us what kind of data would have gone into it.
So these are. So I told you about the map I created for the Nicaraguan village.
I'm trying to figure out why they didn't geocode where the stuff took place.
Because they didn't have the capability.
She did this year, didn't she? No, South Africa, she did it.
Well, so she did this back in the summer. So actually, the way we did this was really interesting. This was a partnership with Kent State, and this is a refugee camp. So it started with Etapa 1, and as each subsequent natural disaster has expanded out. So what we had was this.
Okay.
So this is what the community's been using for years.
That's the hand drawn.
This is the hand-drawn map.
And it's accurate to now?
Yes,
Close?
the shapes are accurate to now. It's actually not spatially accurate, so it can't be taken into GIS and rectified. But so what we did was we took that into the rest of everything. So I took that hand-drawn map and I looked at where those numbers were, and I matched them up with where we mounted 2 cameras that had GPS devices on them on a truck, and we had the truck drive around so that we had GPS locations for the different areas. And then I took those areas and matched them up with our hand-drawn map. I drew these polygons, and I said, okay, this one here is where Etapa 4 neighborhood L or block L is. And then I was able to take, and this is what you have. I was able to take that data and display it as, I don't have it on here, but I have it for, so here we can see Zika cases. Those dots are the number of Zika cases by block in Nueva Vida, according to those polygons I created in the map.
Very cool.
Yeah, so and it's a pretty low tech. So Kent State has been doing a project with these cameras. We told them, hey, we've got this community, and they sent them to us. Another. Let's see.
So the Zika cases are larger circles?
So a larger circle means more cases.
More cases?
Yeah.
And how big is a block?
They're variable, and they're variable in terms of the number of households. We also, I don't have it on here, but we have water levels. So the next step is to take the water levels and other hazards and lay them over and figure out if we can figure out a spatial component to where cases are. Are they closer to high water levels? Are they closer to trash piles? So this is from my dissertation. This is all of the Aedes aegypti occurrences that we have data for in the world. And so these are literally latitude and longitude coordinates. And so I took a map, I took a space that I was going to use for my mapping for my dissertation, and I said, all right, show me where all of those are.
And that's where the particular mosquito
Was observed.
was observed.
Yes, and they're so tightly stacked on top of each other because they're actually at a 1 kilometer resolution. So the mosquito was observed somewhere within that 1 kilometer by 1 kilometer square.
And then they're hotter by red.
Well, right now they're not. They're it's just density. This is just a density map. But we can see why Brazil has problems with Zika because this is a Zika mosquito. I'm trying to think if I have
So
it.
where did you get the data?
So there was a publication in 2014 by Kramer et al., which is a team out of the London School of Tropical Medicine and Hygiene, that had compiled a whole bunch of global publicly available data, Ministry of Health surveys, researchers they know who have done systematic data collection of mosquitoes in certain areas, and they compiled all of it.
Oh,
So it's a publicly available data set source. It's actually on hosted on GitHub, so you can just go download it. And then I'm trying to think if I have probably one other one on here I can show you.
So mean, to me, it's almost like a challenge is finding the common denominator of space of the linker, right?
Right.
So when you like, how high resolution are coordinates?
So coordinates are incredibly high
Yeah,
resolution.
I mean that should be down to the
Yeah.
down to the foot, right?
Yeah. So those are
So-
incredibly granular.
So if you can geocode things based on coordinates, which we all can because we all have cell phones,
Right.
and they're all GPSs.
Yes. So there's actually been some discussion of how to do that for Liberia and Ebola. So when they were trying to map Ebola cases, they were having problems with like, okay, this village is named Chocolate City, but this village over here is also named Chocolate City, and that village over there is Chocolate City. And so which one is actually Chocolate City, and where is it? So we've got it over here on the map, but there was a flood there 2 years ago, and so the village actually picked up and moved, and it's over here now.
Wow. Yeah.
And so there are a lot of problems with how do we, and one of the goals was actually to give cell phones to field workers and say, all right, when you're standing there, and you can do this when you park your car actually, you can pull up your map up and you can drop a pin where you parked your car. So later when you're walking around Asheville, like you've got a pin there and your phone will get you back to it. So the idea was to take that capability. The really interesting thing about that specific project and why it didn't work was they were given 3 different types of phones. And each of the phone had a different data export mechanism. They did not talk to any of the other data export mechanisms.
That's got to be a fix. There's got to be a fix in there.
I mean, I'm sure that there is,
It's
but
just
it was
data, right? We torture it when it relents.
yeah, but it's. I mean,
Huh.
so they weren't able to actually do this mapping project because they didn't all use the same cell phone. But yeah, no, you have an incredible. So the other, and this has come up a lot recently, is the data on your phone can be used to determine all sorts of things. You can actually use metadata to determine if someone's in an affair, based on the phone numbers they're calling, based on where they are, where their phone is at certain times, the time of day they're calling. So there's an incredible amount we can do with these phones in terms of locational for good or evil.
Don't they gonna start doing that a lot more?
They're trying to. So we hear about FISA warrants, and a lot of those warrants we hear about are actually for metadata or positional data. But, yeah. Any other
Positional data is not super
need a warrant?
reliable, right? So like
It's
pinging towers is what I hear about as far as criminal cases.
It depends. So the pedometer in your cell phone is sensitive enough that if I gave you my cell phone and you walked around with it for a little while, they would know I didn't have it because of your gait. So it can be really reliable, but if I could convince them like, oh no, Billy had my phone when that murder occurred. I didn't do it.
I mean, isn't that how they determine, like, on your GPS, like when you're driving and sometimes it'll tell you if there's a green light or a red light? Don't they determine that by, like, how many cell phones are stopped
Yeah.
at one spot?
Anonymized
Yes.
positional data.
Yes.
Sure.
So what your cell phone does is it triangulates. So if you're here, it finds 2 cell phone towers and it figures out how long it takes to ping off that tower and how long it takes to ping off that tower. And based on that time, it says, okay, you're here. When you move to the next tower, it says, all right, it took 30 milliseconds to ping off of that tower, so now Julie must be here. So based on the number of phones pinging off the tower, it can say, oh, this many phones are here. Now there's also apps like Waze, which can say this many other users are using this app and pinging. And so here's how we calculate density based on that. Waze is a really interesting case because it was created in Israel to help Israel and Palestinian persons avoid potentially deadly conflict zones. So you could put in I'm Israeli, and it would direct you around Palestinian conflict zones. So I'm Palestinian, and it would not take you through Israeli safe zones. And now we use it to avoid traffic.
Yeah, I used to the other day in
I
DC.
I love it.
4 o'clock in the afternoon, took me through a neighborhood.
Yep.
Killer.
So yeah, it's really what we can do with geodata, what's going to happen with it. So geoscience is really, GIS has really become a thing in the past 10 years. 15 years ago, they were still hand-drawn maps. So this is a really interesting time to be in this field because we just started figuring out what we can do. Any other questions, comments?
That's fascinating.
I can nerd out about this for a while, so.
It's awesome. You basically have a superpower. Yeah. I mean, it's what you did with the refugee camps.
That's actually one of my favorite projects I've done.
Yeah.
So if you'll put your email address on here legibly, I will make sure everybody gets, and I'll probably get them to send the PowerPoint maybe out to the college, we'll see. But definitely put your email address down so I can make sure you get it.
So I want to nerd out about this for another second.
I'm gonna stop the recording.
Because there is an ethical